Longest zigzag path in a binary tree. We are given the root of a binary tree. A zigzag path for a binary tree is defined as follows. We have to choose any node in the binary tree and a direction right or left. If the current direction is right, we have to move to the right child of the current node, otherwise move to the left child. So if we follow from here and our initial direction is right, we have to move right, and then update the direction to left. And once we have our direction is left, we have to move leftward, we can't go right, and then update it again to right and then go right, and we have to keep on doing this. Change the direction from right to left or from left to right. Repeat the second and third steps until you can't move in the tree. Zigzag length is defined as the number of nodes visited minus 1. A single node has a length of 0. So in this example we visited 1, 2, 3 and 4 nodes. So our zigzag length is 3, which is 4 minus 1. In this example here, we have to return the maximum zigzag length in this binary tree. We will start at 1, and let's suppose our initial direction is left. Then we have to move leftward, but there is no node in the left direction, so we'll just omit that. Then our initial direction will be right, so we will move in the right direction and update the initial direction to left, and then we have to move leftwards, and our zigzag length is 3 minus 1, which is equal to 2. And then we'll move to this node here. Let's suppose our initial direction is left, and then we will move here. Our zigzag length is just 1 because there is no node after this. But in the other case, let's suppose our initial direction is right. We'll move rightwards, then update the initial direction and update the direction to left. We have to move left and then right, and that's it. This is our longest path. If we keep on doing this, explore all the nodes and all the paths, all the zigzag paths, this will be our longest uh, length of a zigzag path, which is we have 1, 2, 3, 4 nodes. 4 minus 1, which is equal to 3, and we will return 3. First of all, we will check if the root is empty. If not root, we will return -1. Otherwise, let's initialize a variable longest path length is equal to 0, and a function path. I will create a function path. In this we will pass in a node parameter, current length, and also the direction. I will explain to you what we are doing in this function. So what we have to do is initially we will pass the node to this current node to this path function, and also the current length of the path, and the direction we moved previously, and we will call it recursively in zigzag direction. If previously we had called left, now we will call it right, and we will append increment the current length as well and move the node as well in the corresponding direction. In that way we can find the longest path length. So let's start. If not node, what we will do is we will return 0, meaning this is the base condition, meaning we reach the end. Otherwise we will, in each recursion, what we will do is we will find the maximum, like we'll update the longest path length if we have found the longest path until now, which will be self.longest path length comma current length, and let's name it current direction. Okay, so this is current length and this is current direction. So we'll update the longest path length in each recursion call by checking if the current length is greater than the current longest path length, and if the current direction is left, what we will do is we have to move rightwards now. So we'll call this path function again, and we'll pass the right node to it. We'll move rightwards. Current length will be +1 because we have moved to one more node, and also the current direction will be right because we moved rightwards. And also we will check for the left node as well, but in that situation we will reset the current length, so it will again be 1, because we are not only starting from root, we also want to check from the middle of the tree, like if we find any longest path length. So we will reset it. We'll reset the current length, pass the node dot left to it 1, and this should be left because we moved leftwards. Otherwise, if the current direction was right, or we can just write else if the current direction was right, meaning, so path will pass a node dot left this time because the current direction was right. Current length +1, and now the current direction will be left because we are moving leftwards. And again, same thing, if we moved rightwards previously, and if we want to move right again, in that situation we have to reset the current length. We'll pass node dot right, and current length will be 1, and we are moving rightwards. That's it. That's our path function. Now we just have to call it. So we won't pass in root because if we pass in root, we don't know the direction. We'll call it 2 times. We will pass the left node of root and right node of the root. Let's do that. Root dot left. We'll call it on root dot left. Length will be 1 from root node to left node of root node, and direction will be left because we moved leftwards. And also for right node, root dot right, comma 1, comma right. And also say after calling this path function recursively, we'll have stored the longest path length in this variable, and we can just return it. Let me copy it and paste it. Let's try it out. So what's the error? Tree node object has no attribute left. Spelling mistake. Thank you for watching this video. Please subscribe to my channel.